I'm going to go over a railroad crossing malfunction that nobody has really talked about yet, especially with all the different types of mechanisms I have. I have an S60 gate mechanism, solid state, a Western Cullen Hayes Model 3590 gate mechanism, and I also have a Type S gate mechanism right here by SafeTran. And that is important with this crossing setup, as with these different gate mechanisms, they operate slightly differently. Okay, I dropped the voltage and I actually got rid of the battery that was inside of it, so the jumper is no longer connected to the battery. It's literally connected from the battery charger directly to the signals, and it bypasses the battery. And the reason why batteries are important is because they actually give the amperage that the signals need. When the gates go down and go back up, the battery charger can only charge the battery up at a certain amperage. And the battery will actually pull the extra amperage when the gates activate and when the gates pick back up. So batteries are very important. Without the battery, you will need a much larger transformer to actually power up the crossing signal. And here we go. I'm going to pick the gates back up. And as you can see, the WC Hayes gate mechanism is never going to pick up all the way. Okay, this is where it's going to get very interesting. So I actually ended up increasing the voltage on the crossing signals, and again, without the battery, so I don't have enough amperage, but I'm going to add too much voltage to these crossing signals, and we're going to see what happens. Okay, nothing interesting yet, but going to let the gates back up. Yes, 60 sure making a lot of noise. What is actually going on the signal side with the low voltage problem is the crossing mechanisms mainly. All the lights are on one flasher relay, so the low voltage problem going to the flasher relay is the same throughout, even the LED and incandescent lights. It is just the same. So I'm not really going to go over much on that. It uses a FN16A flasher relay. And when you put 10 volts to it or less, it is going to start flickering real fast or not properly at all. So now the mechanisms are what I'm going to go over. And like I said at the beginning of the video, these are three completely different types of gate mechanisms. Here's the inside of the Model 3590 gate mechanism. And the problem with this one is a hold clear failure. It is not able to engage with the low voltage problem as seen at the beginning of the video. And so I'm going to activate it real quick. Okay, as you can see, the gate drops fine. as it does not need a lot of amperage or voltage to drive it down. But when it drives up, it's going to need a lot of energy. And as you can see, the hold clear hasn't even engaged yet. Okay, as you can see here, the hold clear device hasn't engaged, as there is not enough voltage going to these coils to actually magnetize this. Here's the inside of the S60 mechanism. There is a solid state driver board. Here is the motor, and there's the reduction gears right there, which you'll see is the exact same as in the Type S gate mechanism when it comes to the actual size of the gears and the actual gear reduction. But with this motor, it actually has extra gears in this gearbox on the actual motor. And so when this side spins right here, and this is engaged, so I'm going to be very careful, but this is actually able to slide. And the reason why I'm able to actually turn it is because this is a brake and it is able to actually slip. And the reason why the gearbox is there is so they can have a smaller motor, as with more gears, the less torque you need on a motor, so the smaller it can be. And the hold clear device is now gone and is now this brake type, as it is just smaller, there's less torque applied to it, and there's no need for a very big hold clear device to hold up this gate. So anyways, that is also the reason why this gate drives up first, because it has the least amount of torque applied to it and it takes the least amount of energy to drive into the up position with the extra gear reduction. But the motor does have to spin much faster, and so there is actually more noise associated with this gate mechanism. But all in all, this is a very good gate mechanism. I'm now going to activate it so you can see what happens. Okay, and as you can see, that side is spinning much faster than this side. So you can actually see the gear reduction speed difference. Here's the inside of the Type S. Here's the hold clear device, the giant motor, and the gears. I'm now going to drop this gate. Okay, the hold clear device is now open, and it will engage. This one doesn't have any issues engaging with a lower voltage, lower amperage problem. And you can actually hear the mechanical bell up there clicking. There's not enough voltage to actually bring the hammer to the gong and make a sound. It's not able to hit the gong. Okay, now I'm going to lift the gate back up. And that is going to be the relay. It's energizing and de-energizing pretty rapidly. Once there's enough voltage to actually run it, it will then pick up the gate.